Okay, so here we go. So number 5. A bar 5 meters long has its center of gravity 1.5 meters from one end. So draw the bar. It is 5 meters long. Center of gravity is 1.5 meters from one end. Again, I always just use a big fat X to mark the center of gravity. I keep alternating between center of gravity and center of mass. They're not technically exactly the same thing, but unless you're talking about something super huge like, you know, the Empire State Building or something, they're so close. I mean, they're within, you know, a molecule of each other, so it doesn't really matter. So if I say center of mass or center of gravity, it's basically the same thing. All right, so this is 1.5 meters to the center of mass, center of gravity. Let's see. It has one support 1.5 meters from the light end, and a weight of 750 newtons is placed on the bar at the light end. So which end of the board is the light end, you guys? This end, right? The end farther from the center of mass. Is everybody cool with that? All right, and so the problem tells you that there's a support placed 1.5 meters from the light end, and there's a 750 Newton weight suspended there. Okay? What is the mass of the bar? So if you need a visual, it's something like this. You've got a weight at one end and a support here, and you're trying to find the weight of the bar. Follow? All right, so this is actually a really good one to talk about your positives and negatives on. Oh, darn it. I wish I'd drawn it the other way, though, with that in mind. Okay, so are we good with the drawing? All right, so then the question says, what's the mass of the bar? So, remember, there are two types of problems. Two unknown forces, or unknown force, unknown distance. What do we got here? Two unknown forces, right? What are the two unknown forces? It's the force of gravity from the bar itself, right? The bar has weight, and the support is holding it up, right? All right, and then let's just give this a name. We'll call this the force of the weight that's hanging from it. All right, everybody good? Okay, so my recommendation to you guys has been, if there are two unknown forces, which there are, pick one of those unknown forces to be your pivot point. Okay? So in this one, we're trying to find the mass of the bar. So we got to find the weight of the bar, right? So where should I pick my pivot point to be? Yeah, let's pick the pivot point at the support. Because then what will happen is the torque from the support will be 0, and we'll solve for the force of gravity here of the bar. Follow? Any problems? Okay, so let's smallify this thing. Boo. Gotta make sound effects or it won't work. All right, so here we go. So the whole idea then is our net torque has to be 0. So that red dot, let's call that point P, is in pivot point. So our net torque around pivot point P is equal to the torque from gravity plus the torque from the support plus the torque from the weight hung from the end. Follow? All right, what does the net torque have to be? 0, because the whole thing's balanced. That's got to equal the torque from gravity. So let's see, torque from gravity. So that's the force of gravity, that's what I'm looking for, times what? Well, if this is 1.5 and this is 1.5 and the whole thing is 5, I think we're left with 2 meters there in the middle, right? Does that follow? Yeah. So times 2 plus the torque from the support, which is the force of the support times 0, right? Right? If my pivot point is here and I push here, that's not going to produce any torque. Plus the torque from the weight, which is 750 times, go brain, 1.5. Cool? Questions? Okay.
So for finding the torque of gravity, it's only from the distance that we use is only from the center of gravity to the pivot point?
Correct. Yep, and whichever pivot point you pick, you know what I mean? Your pivot point, in this one, your pivot point does happen to be the fulcrum, but that's not necessarily always true.
So it's just a pivot point to the center.
Yep, so it's your chosen pivot point to where your center of mass, center of gravity is. Good? Yeah, Weston's in the back, guys.
Hi.
Hi, everybody. My name's Weston. I like water skiing. I'm sorry, what's up?
When you say you like to take your pivot point, why do you say there are some places that are better to do it versus other places?
I mean, it doesn't really matter. So if there are two unknown forces, there are only two choices for your pivot point. Okay? If there are two unknown forces, your pivot point has to be where one of those unknown forces is. Good? All right. Now, which one you pick doesn't really matter. Okay? I thought ahead a little bit on this one because in this one we're looking for, if you're looking for both forces, then it matters 0. Okay? But if you're, the question here, we only need to know one of the two forces to answer the question, right? Like all I gotta do is find this force of gravity. Once I do that, I'm more or less done, right? So when that happens, if you only care about one of the forces, then choose the other one as your pivot point.
So don't choose the pivot point of the one you can't find?
Correct.
Okay.
Does that make sense?
Yeah.
Why? Because what happens to the one you pick? It becomes a torque of 0, so it just goes away anyway, right? You see what I mean?
Yeah. Because when I came in earlier talking, I forget who came in, and they were like, you said there's 2 good spots, like one.
Oh, gotcha. That's for the other type of problem.
Oh, this has nothing to do with what you're doing right now.
Right, yeah.
Okay.
So that's for, I know what you're talking about. But yeah. All right, so are we all good? All right, now, please hear me say this, you guys. This is one of the common mistakes I see people make. All right? Notice, I didn't put any signs in here. Even for the negative forces, I didn't put signs in, right? So here's what I want you to do. I want you to leave your signs out until you've got this equation written, then determine the direction of your torque and put the signs in. Okay? So if this is my pivot point, grab a thing. So here's my beam with my pivot point where my hand is. Gravity's pulling down, right? So is that going to make it spin clockwise or counter? Counterclockwise, right? So this force of gravity's got to be, oh shoot. I wish I hadn't just done that. All right, so my guess is this is going to be positive, all right? It's not actually a guess because we know gravity's pulling down. Let's pretend for a minute we didn't even know the direction of the force. Okay, just bear with me for a minute. Let's pretend, because I think this is maybe what you're struggling with, Abby, which is why I'm doing this. So let's pretend we didn't know that gravity pulled stuff down. Okay? So, I can't decide the direction of this torque because I don't know this force, right? All right, how about this one? That torque should be negative, right? So I'm going to put a negative there because it's going to make it spin clockwise, right?
Why is it just pulling it down?
Yep, because my pivot point is here. The force is to the right of the pivot point, and it's going to make it
Okay.
cool. Is that a genuine cool or a...
Yeah.
All right. Everybody good? All right. So solve this, and here's what I wanted you guys to be conscious of. So when you solve this, you get 750 times 1.5, and you move it to the other side. So what's 750 times 1.5? 1075? 1125. Okay. So you end up getting FG times 2 equals, after you solve it, you get positive 1125. All right, so look, you guys, this is a subtlety that hasn't come up very often, so please follow along here. All right, so this value here, that's the torque from gravity, right? And I found out that that torque has to be positive. So if I'm going to apply a force here, and this is my pivot point, what direction does that force have to be in to make my torque positive? Down. Let me say that again. We know that the torque has to be positive because we did the math and we found out that the torque from gravity has to be positive. Okay? Here's my force of gravity. Here's my pivot point. So if this is my pivot point, which way do I have to push here to make it spin in a counterclockwise direction, right? Because positive torque is counterclockwise. So which way do I have to push?
Down.
Down. Huh? Oh, that force must go down. Make sense or not? Cool. So solve it. Your force of gravity ends up being negative, whatever half of that is. What, 612.5? That's not at all right, is it? How about 662.5? 675, 65, math. How about 562.5? Is that right?
Yeah.
Cool. Cool? Questiones, issues, concerns? All right, how could I now very easily find this missing support force? Set your net force equal to 0, right? So you would go, so our force of gravity was negative, what did we say, 562.5, plus the force of the support, plus the force of the weight, equals 0. And so it's going to give you, yeah, 12 something. What?
This 5.
Yeah, so question 5, oh shoot, I'm sorry.
Yeah, I think you're combining on parts of 6 with the 5. It is absolutely.
Yeah, no. And I said, what if it had asked for the force of the support?
Oh.
How would you find that? And the answer was set your net force to 0 and solve. All right. I did realize, though, halfway through that little exchange that I did skip a step. The question doesn't ask for the weight of the bar, it asks for the mass of the bar. So how do I use this to find the mass, you guys? Just divide by 9.8. Cool? Questions? All right. Any problems? Okay. So that did not go as smoothly as I had hoped it would have.